Welcome to Stiochiometry Made Easy with Book. In this video, we're going to learn what is stoichiometry and how to solve one-step stoichiometry problems. But before we begin, let's start with a question. Which of the following always contains the same number of atoms? 1 gram of atoms, 1 mole of atoms, or 1 liter of atoms? The correct answer is B, 1 mole of atoms, which is equal to 600 billion trillion atoms. Remember that just like a dozen is 12 things, a mole is simply a very large number of things. And because the mole refers to the number of things, we will need to use the mole extensively when we do stoichiometry. So, what in the world is stoichiometry? The word comes from 2 Greek roots, stoichion, which means element, and metron, which means measure. Basically, stoichiometry is a scientist's way of measuring elements and other chemicals in a chemical reaction. It's a lot like the way a chef measures the ingredients of a recipe. In fact, chemistry is a lot like cooking. Imagine for a second that you're home alone and craving some grilled cheese sandwiches, but you don't know how to make one. So you call up your friend and say, "Hey man, how do you make a grilled cheese sandwich?" And he says, "Dude, chill. It's real easy. Just take some bread, put some cheese in the middle, heat it up, and you got yourself some grilled cheese." How much bread? How much cheese, you ask? 2 slices of bread and 1 slice of cheese is all you need to make one sandwich. So there you go. You've got your recipe. In chemistry, the recipe is the balanced chemical equation. So where does stoichiometry come in? Let's suppose you are super hungry and you want to make 7 grilled cheese sandwiches. You need to know how much of each ingredient to use. Let's start with the first ingredient. How many slices of bread do you need to make 7 grilled cheese sandwiches? You can probably solve this in your head, but please follow the logic of my method. In order to solve this problem, we are first going to write down the quantity that we know, 7 grilled cheese sandwiches. Next, we are going to multiply this by the ratio of bread to sandwiches. You need 2 slices of bread to make 1 sandwich. Where did I get those numbers? The recipe, or the balance equation, tells us the ratio of the ingredients and products. Bread and sandwiches are in a 2-to-1 ratio. We put the 2 slices of bread on top because that is what we are solving for, and the 1 sandwich on the bottom because that is the quantity that we started with. Sandwiches on the top and bottom cancel each other out, and we are left with 7 times 2 slices of bread to make 14 slices of bread, which is our final answer. Notice that this is really a unit conversion problem, and the balance equation is our conversion factor. Okay, now we're going to do the exact same thing with chemicals that we just did with food. Check out this reaction. Nitrogen reacts with hydrogen to produce NH3, which is called ammonia. This reaction is known as the Haber process, which is primarily used to make fertilizer. Fertilizer helps crops grow and becomes part of our food. In fact, more than half of the nitrogen in your body probably comes from this reaction, so it's pretty important. As it's written, the reaction is not balanced. There are 2 nitrogens on the left and only 1 on the right, so we put a 2 in front of ammonia to balance the nitrogens. This gives us 6 hydrogens on the right side, but only 2 on the left, so we put a 3 in front of hydrogen. Now the reaction is all balanced. Remember, our balanced reaction is our recipe, so what is it actually telling us? The balanced chemical equation tells us that 1 nitrogen molecule reacts with 3 hydrogen molecules to make 2 ammonia molecules. Well, what if we have more? Let's say we have 10 nitrogen molecules. How many hydrogen molecules would they react with? That's right, 30. And the reaction would produce 20 ammonia molecules. The balanced chemical equation tells us that nitrogen, hydrogen, and ammonia are always in a 1:3:2 ratio, no matter how big or small the reaction is. So, let's talk about a large amount of nitrogen. The air you breathe in every minute when you are walking contains approximately 600 billion trillion nitrogen molecules, which is equal to 6 times 10 to the 23rd. Does that number look familiar? Yes, we're talking about 1 mole of nitrogen. And 1 mole of nitrogen will react with 3 moles of hydrogen to make 2 moles of ammonia. Where am I getting those numbers? They are the big numbers in front of the chemicals